All right, guys. Good morning again. Thank you for participating in office hours. We have a new arrival here today. We have Sawyer. Thank you for arriving. So we're going to go over the last topic of this week regarding trigonometry and from Khan Academy. One of the last topics within the pacing calendar that was given this week was this concept on cofunctions, like the relationship between sine and cosine. So unfortunately, Khan Academy didn't have enough practice exercises related to that topic, and even more unfortunate, on the Regents, from time to time, from exam to exam, you will see either one or two questions, okay, directly related to this topic. So I think it would be beneficial for me to talk a little more extensively on this and to give you guys more opportunities to practice on this topic. Okay, so let me show you what I mean, about what I just said. I'm going to share screen. Okay, so what I have now, okay, is this scenario right here. Okay, and I'm going to ask you guys to take a moment and copy this information over here. Okay, write that information down. Okay, and if need be, okay, if you need this, okay, write this information down as well. But I trust that everyone here, having gone through the various assignments from last week and from this week, I think the material, that information there highlighted on in yellow on the right there, everyone is pretty proficient in. Okay, so if you feel like you don't need to write that, that's okay. But at the very least, write down what's in pink there. Okay, and we're going to go over that.
Mr. Chan, what is the sign at the top of the triangle that resembles a B?
Say that one more time, Michael.
What is the sign at the top of the triangle that resembles a B? Yeah, that one.
Right there?
Yeah.
That's beta.
Beta. Is it the same as theta?
It is another Greek symbol. So it's a Greek alphabet. Beta, typically used to represent unknowns and typically used to represent angles. So similar to theta, yes.
Oh, okay.
Can we zoom back?
Yep.
Ooh, need to copy that.
So take a moment just to write that down. So everyone have this yet?
I have it.
You have it, Mike? You have it? Awesome.
Don't.
All right. So
I don't.
All right. I'll give you another 30 seconds. All right, so we're here. We got it? Yes?
Yeah.
Yeah, I'm good now.
Okay. So let's talk about this, right? So, I left these things here blank for a reason. That's because we're going to try to figure out what they are. So with our understanding of sine, cosine, tangent as it pertains to right triangles and trigonometry, right? Can I maybe Michael, can you tell me what will sine theta equal to in this situation?
Sine of theta will equal to what does sine equal to again?
So
So
if you don't remember,
oh wait, I'm trying to remember. Sine is equal to opposite over hypotenuse.
that's right.
So it's 3 over radical 13.
3
Do
over
we need to
radical.
simplify that?
That's an excellent question. So, uh, on the regions, not so much in geometry, but in like algebra 2, okay, there is something called rationalization. And I briefly talked about this when we were in school, right? Does anyone recall what that was? Michael, you remember?
It means there's no irrational number like square root of 13 at the
Square root of
bottom.
13 is irrational. That's true. But what does it mean to rationalize, though? Does anyone remember?
Yeah. It means to multiply both sides, top and bottom, by the denominator.
Yeah, multiply
Yeah,
top
I
and
was
bottom by the
about to say
denominator
that.
by what that radical is. And this turns out to be 3 radical 13 over 13. That's what sine
Yeah.
theta is, right? We're going to repeat this again. We're going to try to figure out what is cosine of beta, okay? So maybe Sawyer, can you tell us what is cosine of beta?
Cosine of beta is 2 over square root of 13. Oh, no, wait. Cosine of beta? Oh.
Mm-hmm.
Is it's 3 over the square root of 13.
That's right. It's 3 over square root of 13. And, without having to do the work again, this will be equivalent to, again, 3 radical 13 over 13. Do you guys see anything surprising here?
That they equal each other.
That they're the same things, right? Wasn't that one of the points that was emphasized in the videos, right? About those co-relationships between sine and cosine, right? All right. So again, the emphasis right now is that sine of theta and cosine of beta, they end up equaling to the same things. What I want you to do, okay, let's just take 30 seconds and think about how we can do the following. I want you to figure out what is theta equal to? What will the angle theta equal to? What would we have to do to figure that out?
Do we do arc sine?
We certainly will do arc sine. So we're going to say arc sine. Michael, what do we put in for arc sine?
3
Yeah, you can do that. Sure.
3 radical 13 over 13.
That's right. So 3 radical 13 over 13. And I want you to take your calculator and I want you to actually punch that in and tell me what you get as a result. Who here has their calculator handy?
Me. I have
Mike,
it.
do us the honors.
Okay.
And I want others to do the same, just to confirm, because it's good just to check on everyone's work.
Of 3 radical 13 over 13. It is 56.3099.
Like that?
Yep.
Okay. And maybe Emmett, can you tell us what to do to find out what beta is?
You do this same thing. Well, not the same thing. It's arc cosine and then 3 radical 13 over 13. I have my calculator handy, so I'll do the honors.
Yep.
Even though I probably know the answer.
All right, sure, you do it. My calculator is running low on battery anyway. I haven't charged it since Monday.
I got 33.69.
Okay, so Kian, are you there?
Yeah, I'm here.
Okay, so I want you to tell us what would theta plus beta equal to.
All right, let me add this up. Give me a second.
I have a guess.
All right, when Kian tells us what that is, and then I want you to tell us how you came to that hypothesis, Emmett, okay?
So we just add up theta and beta. So that would be 89.9999,
Or just approximately how much?
right?
Yeah, approximately how much?
90.
Approximately 90, right? All right, so I want you to, take a good look at this, okay? Just because sometimes when we look so close at something, all we see are dots, right? So I want you to take a step back and look at this, okay? Could we have actually arrived at the same conclusion that theta plus beta will equal to 90 without having to do all this stuff? Again, my question is, did we know theta plus 90 was going to equal, theta plus beta was going to equal to 90 since the very, very beginning of the problem? Did we know that?
Yeah.
Sorry, how did we know that?
Because there's 90 degrees. There's a 90-degree angle in the triangle, and it's a 180-degree triangle. Well,
Yeah.
and
Thank you, Emmett,
there's
right?
only 90 degrees left.
So again, this and this together, or actually all three of these together, right? They should all add up to 180, right? Since we have a right angle in there, that means the remaining angles, theta and beta, must equal to 90. Agree?
Yeah.
Okay, so my other observation, okay, or the other observation I want you guys to make, okay, is this, okay? Do you think it was a coincidence that that sine and cosine of those two different angles turn out to be the same things? Do you think that was a coincidence, or it was just like that it's going to happen every time?
It'll happen every time.
So Emmett is hypothesizing that will happen every time, okay? And actually, if you look a little closer at this, right, like the side length that's opposite of theta, right, will in turn always be adjacent to the other angle. Can everyone make that observation with me?
Yeah.
Right? Like side length 3, right? This guy right here. That side, let me use another color now because it's getting kind of busy. So one more time. This side length 3, okay, will always be opposite of theta, right? However, 3 is also adjacent to which angle?
Beta.
The beta, okay? So for that reason, okay, the sine and cosine values will always end up being the same things. This is not a coincidence. This will always happen, okay? And in mathematics, okay, we actually refer to this as an identity, okay? When you think of the word identity, okay, you think of like something that defines something else, right? That's what it means, like literally, what an identity is, okay? So something that defines something else. So in this case, okay, this relationship, okay, is what's defining sine and cosine together, okay? So let's take a look at another example where this property, where this identity, okay, repeats again, okay? And again, to reiterate that this is not a coincidence. Let's take a look at another scenario. Let's take a look at this guy. Very, very similar. Okay. So take a moment again. I want you guys to copy down this situation here. Whoops. Copy down this situation here. Again, these are the notes that I want you to photograph later on. And when I make up the assignment next week, okay, you are to upload that information into the Google Classroom assignment. You guys got it?
But so you're not going to post it this week?
I'm not going to post it this week because I've already posted all the assignments for the week already. So I'm not going to add on additional things. So save these notes, okay? When the assignment comes up next week, all you got to do is just photograph this and upload it, okay? Let me know when you have that stuff highlighted, written down.
I have it.
Okay.
Got it.
Got it, Keaton? Okay. Michael, you got it?
Wait, do we already know the answer? To the
Yeah, I
bottom
got
one?
it. I'm
Okay.
just copying it. Yeah, I just copied the triangle. Yeah.
Okay. Calvin, do you have it?
You said no.
Mr.
No.
Chan, do we already know the answer to the
No.
bottom one?
That's right. Having gone through the material from the step above, yes, we do.
We just have to find out what theta and beta equals. But we already know what theta plus beta will equal.
That's right.
I copied it.
You copied it? Awesome. All right. So let's take a look at this example here now. Okay. So, Kelvin, can you tell me what is sine of theta going to equal to in this case? I want opposite.
Opposite over hypotenuse.
That's right. Which side will be opposite in this case? So
3.
theta is over here, right?
3.
Which side will be facing it? Which side is facing angle theta?
3.
It actually is 4 here. So again, what it means to face something, right? You're looking directly at it, and like that, okay?
Right.
It's okay. That again, like I said last time, right? I've had a lot of difficulty with language, okay? And this was one of the things that I had struggled with. So 4 here, okay, is going to be the side opposite. Kian, which side is hypotenuse in this case?
Radical 21.
Radical 21. And then we're going to rationalize this, right? So, Michael, how do we rationalize? Michael?
Yeah, I'm here. We rationalize by multiplying both sides by the denominator. So that's what
Right,
make it
the top and bottom by what the denominator is. So if we do that, we end up with 4 radical 21
over 21.
21. So that's sine of theta. We're going to repeat this again for cosine of beta. Maybe Kian, can you tell us what that is?
It's basically the same thing. So it'll be 4 over radical 21 times radical 21 over radical 21 equals 4 radical 21 over 21.
That's right, okay? And again, if you need convincing, again, the side adjacent to beta would be 4, right? And again, the hypotenuse is 21. So again, we're going to end up with the same thing. So this is not a coincidence, as we are seeing, okay? All right, so now to find out what theta and beta is, okay? Do we know what theta is and what beta is without having to go over this? Or do we need to actually do math in order to figure out what individually theta and beta is?
We need to do math.
We actually need to do math, right? We actually need to go through this. Maybe Emmett, can you tell us how to do that?
Yeah, so wait, for theta?
Yeah.
All right, so we do arc sine, and then in parentheses, 4 radical 21 over 21, and then we put in the calculator, and then you get 60.79.
And then Sawyer, can you tell us what beta is?
Beta is you take it's 29.21.
29.21. I totally agree. Like, can you tell us what like how did you arrive at that?
I took the I forgot what it's called, but the cosine, the opposite cosine,
So arc cosine.
and then I did 4 by the square root of 21 divided by 21 is equal to 29.21.
I totally agree. Okay, and then if you were to add them together, you would end up with 90. That's if you didn't know that identity, right, from before. So they will equal to 90 degrees. Okay, so again, it is by no coincidence that that will happen. Okay, that sine of theta and cosine of beta will always end up being the same. Okay, and we have to, and this is the other part here. Okay, that theta and beta will always equal to 90. Okay, so I want to talk about how we can maybe sort of generalize this. Okay, so what has to be true then is, okay, we can then jump to this conclusion right here. Can everyone write that down?
Wait for me. I'm just copying it. Let me just copy it. Is it for the triangle we just did a while ago?
This is actually true for any right triangle that you ever create. Okay, so why is this true, or how let's just think about this. Okay, what is the relationship? Okay, let's just think about this. So I have angle theta in here, and in the other examples that we went through in the last like 10 minutes, okay, we called the other angle in here, what do we call that?
90 minus theta.
We call that other
Theta.
angle not theta, but we called it
Beta.
we called it beta. That's right. We called that other angle beta. But what is the actual relationship between theta and beta?
They equal 90 if you add them together.
They equal to 90 if you add them together, right? Wait, isn't that the case that we have right here?
Yeah.
Yeah.
Right? That's all. That's what that's saying. So sine of an angle will equal to cosine of another angle if those two angles add up to equal to 90. Okay. So then another way of thinking about it then, okay, another way of thinking about this, okay, you can think of beta. I'm gonna add this in here. You can think of beta as 90 minus theta. Isn't that true? Right. That's another way of thinking about it as well. That the angle that in cosine will equal to 90 minus theta. All right. So this is what we call the co-function identity. This is what we call the co-function identity. Okay. So the okay, in co-function identity here, or in the word cosine actually is a prefix, okay, for the word complementary. Why do you think the word complementary is thrown in here?
Well, because the complementary angle is 90 degrees.
Yeah, two angles that are complementary with one another adds up to 90 degrees. Okay, so the nomenclature, right, That's a bit of a scientific word for you guys, right? I'm sure you guys study it in life science, living environment, right? Because there's a lot of nomenclature that goes into science. There's a lot of nomenclature that goes into math as well, okay?
I mean,
And in languages. So the word co, okay, is actually a prefix for complementary, and it stands for like things adding up to 90 degrees, which is very fitting for the situation here, okay? So we're dealing with a sine function, and sine is defined as opposite over hypotenuse. Then the co-function, the complementary function, would be cosine, okay? And we define that as adjacent over hypotenuse. Anyway, this is the identity that we're going to use, okay? This identity is not particularly useful until you get to like higher level math, unfortunately, okay? So for the time being, you look at this and you're like, okay, so what? Who cares? But it becomes more useful when you get into more challenging situations where you're trying to like prove other things, okay? Which is why it's introduced in this level of geometry course right now. So it's thrown in there so that you have an introduction to it, okay? So let's see how we can actually like apply this, okay? Now that we understand this identity, I want to ask you guys to take a moment here. Let's just write down these two problems that's underneath that. Take a moment to write that down. So I have sine of 30 is equal to cosine of A.
wait, that says 20.
I'm sorry,
That's
sine of 20 is equal to cosine of A. And the question is to find out what A is. Okay, and then the second question there is cosine of 35 is equal to sine of B. And then to find out what B is. I want to give you guys 30 seconds to think about this, okay, to apply that identity that's from above, okay, that we had just gone through together, okay, and to figure out what that is. This, again, by itself doesn't have much applications, okay? It's very theoretical. Unfortunately, at this level of like of your understanding, that's you just need to know how to use and work with, okay, these concepts. Are we ready to think about talk about this?
Yeah.
Because
Sure.
the computation required for this problem is like less than one step. Okay, actually, no, it's just one step. Okay.
Is it
What
20?
makes it so easy?
What makes it so easy, Michael? Do you know what makes it so easy?
You're just combining two functions together. No need
You
to.
kind of are. Okay. Let me ask you, Michael.
Okay.
Angle A and angle 20 must add up to how much?
Angle A must add up to 90.
Add up A. Oh wait, angle A and say that again.
Angle A and angle 20 must add up to 90.
It must add up to 90. That's it.
Oh,
So what would that be, Emmett?
you can do 90 minus sine 20.
Oh yeah, you're right.
You actually don't have to figure out what sine 20 is. It's simply 90 minus 20. That's all it is. It's 90 minus 20.
Just 70.
Oh, that's all.
So that's
Oh.
just 70.
That's 70.
Wait, why don't we
Let's
need to
bring
find
the
the
code down.
sine of that?
Say that again, Emmett.
Why do we need to find the sine of that?
We don't need to because the task is to just figure out what this guy is, right?
If we're trying to find out what cosine was.
We're not looking for what cosine is. We're looking for what A equal to.
No, I'm saying if we are looking to find cosine itself, then we'd be looking for that.
Yes, that is true. Okay, if we're looking to find out what cosine of A we're equal to, then we would need to figure out what sine of 20 equal to. Okay, guys, I just mental check here, right? Can everyone do me a favor? If you have a graphing calculator handy, right, and I'm going to do this on the screen as well. Take a graphing calculator and let's just quickly do a mental check here. Let's type in sine 20 and then let's type in cosine of 70 and let's see if it actually comes out to be the same things. Don't want to take over.
Sine.
So you're going to type in sine of 20 and press enter. And we end up with 0.342. And if I type in cosine of 70, let's see if it actually comes out to be the same exact things. And indeed they are. Okay?
Incredible.
To be the same exact things.
Is it because of the co-function identity? That's why?
That is because this is due to sine and cosine are co-function identities. That's it.
Oh,
Okay?
wow.
So let's go back to this. Okay, now that we sort of like understand the trick, okay, behind these types of questions, okay, let's take a look at how do we find out what B is. Maybe Kian, can you tell us what B is?
Sure. B is 55.
B must equal to 55. That's it. You got it. Let's move on to two other problems that's slightly more complex, but not that much, okay? I'm going to give everyone here like maybe another 30 seconds, okay, to try and figure this out.
If let's say this we had the regions this year, would this be on the regions?
You would see one question related to this. And this is
Oh,
just like one fact that you need to know to be able to answer that question.
okay.
Yeah. And typically this question would come up on like a multiple choice.
Oh, okay. At least you can
And if
just
you guys are
go
planning
through
on
all of
taking
them.
ACT, right, you would very much see this on the ACT as well. Not so much on the SAT, just because the SAT is less of a content-specific test, more of like a logic-based test. However, if you plan on taking like the SAT 2 subject test, then you would see this.
Oh.
I'll give you guys
The
another.
ACT is for juniors.
I'll give you guys another 20 seconds.
So the ACT is for juniors, right?
So some people take SATs and some people take the ACTs. Really depends on where you want to apply, for schools, that is.
Okay. Well, I definitely am counting out the Ivy Leagues. I am not that caliber of student.
Well, I want to be the GM of the Mets, so that's probably like a Big Ten school or an ACC school.
Wait, don't we have to solve this algebraically in order to find out what y is and then plug it in and then just
We do need to do this algebraically. That is true. Let's talk about this, okay? Because though this question looks slightly different and a little more intimidating, okay, it is all the same in principle, okay? And the reason why I say it's all the same in principle is the only fact, okay, that you need to rely on is this. What's the relationship between what I'm highlighting right now?
That they add up to 90.
That's the only fact you need to know. That's it, okay? So recognizing that, we say 3x minus 6 plus x plus 20, that must equal to 90. Right? And then we add them together, 3x and x, okay? We end up with 4x. Negative 6 and 20, we end up with 14, right? And then we're going to subtract both sides by 14.
76.
We end up with 4x is equal to 76. And then divide both sides by 4, right?
Yeah, 19.
So it's equal to 19. Okay? All right. I'm going to give you guys another 30 seconds to figure out what this last one here is, okay? All right. So, Kelvin, can you tell me what is the relationship between these two things that I'm highlighting in green? Like, are they going to be the same, or do they add up to something?
Wait, say it again.
Sure. The stuff that I'm highlighting in green, okay, are they going to be the same things, or do they add up to something? And if they do add up to something, what do they add up to?
Wow, wow, wow. Boom, bum.
19.
They do add up to 90. That's right. So if you take 2y, hold on a second. 2y plus 5 plus y minus 35, they do add up to 90. And again, we're going to go through the same process of solving for what y is. We're going to combine like terms, okay? We end up with 3y minus 30 is equal to 90. Add 30 to both sides. We end up with 3y is equal to 120, or y is equal to 40.
Mr. Chan.
Mr. Chan?
Hey guys, my laptop lost connection.
Oh, okay.
Are you guys able to hear me?
Yeah. I
Yep.
think I remember
guys
when you
able to
were
hear me?
talking about like permission to record a video.
Are you guys able to hear me?
Yep.
Mr. Chen, remember that?
Sorry,
I think
hold
I
on.
figured out what it is.
Okay, tell us, Emmett.
Yeah, I think that because I saw when I pressed like the 3 dots in the bottom right, I could stop the recording, but I'm not going to. But
Oh, yeah, it's also the same for me.
Can you guys hear me?
yeah,
Yep.
Okay, sorry. My internet all of a sudden just went, like it just lost. So anyway, that was what I wanted to go over with you guys. Do you guys have any questions about anything that we've just gone over right now?
no.
No.
No?
I
Okay.
finished all 3 videos early today, so I don't even this week, so I don't even have any work.
Oh, lucky you.
Yeah.
I've been doing it. My birthday's tomorrow, so I'm doing it all before
Okay.
Oh,
Happy
that's
early
nice.
birthday.
How old are you tomorrow, Emmett?
15.
Oh, 15. That's nice.
Happy
I'm
early
just a year
birthday.
older. I'm 16, but that's still nice.
So
Not-
guys, what I'm gonna do, okay, because I didn't go over the enrichment problem that I had posted yesterday in during office hours today. I will do that tomorrow morning instead. Like I said before, save the notes from this session, and when I make the assignments for next week, okay, just take a photo of it and then upload it, okay?
Okay, got it.
Okay.
The same exact question, right?
Say that again, Kian.
Are the exact same questions?
It's going to be the same exact question. That's right.
Okay.
Okay.
Got it.
All right. So
All right, thank you.
I am going to stop here and get ready for Family Circle, and you guys should too then, okay?
All right.
Sure.
All right.
All right.
I'll
Thank
talk to
you.
you.